This is Mrs. Naslund, and today we'll be doing Fluency Lesson 12, Multiply and Divide with 8 and 7. Our learning targets for today are, I can explore patterns in 7s and 8s count bys, multiplication, and divisions. I can develop strategies for finding answers to multiplication problems. Alright, we're going to start actually with our 8s today, and let's look at the patterns that we see. Again, you can use one of our the whiteboards and you can circle and follow along with me, or you can look at what we're doing up here and just pay attention to each of the sets. So, one set of 8 is 1 times 8, which is 8. Two sets of 8s are 2 times 8, which is 16. Three sets of 8s are 3 times 8, which is 24. Four sets of 8s are 4 times 8, which is 32. 5 sets of 8s are 5 times 8, which are 40. 6 sets of 8s are 6 times 8, which is 48. 7 sets of 8 are 7 times 8, which is 56. 8 sets of 8 is 8 times 8, which is 64. 9 sets of 8s are 9 times 8, which is 72. And lastly, 10 sets of 8s is 10 times 8, which is 80. Let's go ahead and read the products of all of those. So we have 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. Go ahead and take a second and see if you can recognize any patterns. You can think back to our other count bys, looking at our 2s count bys, our 4s count bys, all of our different count bys, and see if you can find any patterns that you recognize, or just looking at the products as well. All right. Well, one pattern that you might have recognized is when we compare our 8 count bys to our 4 count bys. So let me go ahead and write all of our 4 count bys on here. We've got 4, and if you know these, you can just follow along. 8, 12, 16, 20. Again, all I'm doing is adding 4 on each time here. 24, 28, 32, wasn't very good too, sorry, 32, it's hard to write on the computer. 32, 36, and lastly 40. So let's see if we recognize any of those products in comparison to our 8s. There's an 8 and an 8, no 12, but we have a 16 and a 16, no 20, but we have a 24 and a 24, no 28, but we have a 32 and a 32, no 36, but we also have 40 and a 40. So you'll notice that it alternates. Every other 4 is also an 8 count by. And if you think about it, it makes sense. If you double 4s, you get 8s, right? So if I double 4, 4 times 2, I get 8. So every other one gives you an 8. So if you know your 4s, you can double those and get a lot of your 8 count bys as well. All right, some other things that you might see when we look at our patterns. You might notice that all of our 8s are even, right? All of the products of our 8s are even. The ones digits of the products follow the pattern of 8, 6, 4, 2, 0, 8, 6, 4, 2, 0. Another pattern that you might recognize, if you skip the 80, so we ignore 80, but then we add the numbers, and we did this before too. If we add 72 plus 8, you end up with 80. If I do 16 plus 64, I end up with 80. If I do 56 plus 24, I end up with 80. If I do 32 plus 48, you end up with 80, right? So it keeps adding up to 80 all the way to the middle there. So that's kind of a cool little pattern that you might have recognized. Another thing that we can do is if we draw a line, if we draw a line here and we do it right above the, right under the fives, you might see a pattern on these as well, right? We've got 8, 6, 4, 2, 0. We kind of pointed that one out. But then we have 8, 6, 4, 2, 0. You'll notice that if we find the same place, so like for example, we look at this first set, and then we look at the first set here, 48 minus 8 is 40. They're exactly 40 away. If I look at the second set, 16 minus 56, it's 40. Same thing here, 64 minus 24 is 40. 32 or 72 minus 32 is 40, and 80 minus 40 is 40, or 80 minus 40 is 40. So as you can see, there are a lot of patterns that exist in our 8s. You can also look at the division factors as well, and you'll also see some patterns in there. You'll see patterns that when we take all of the products that we found over here and we divide them by one of the factors, then we get 8 all the way across. And then if we divide them all by 8, then we get it adding up 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, we talked about this before, but if we look at these, you can rearrange these numbers, in different ways. So I can say 8 divided by 1 equals 8, or I can say 8 divided by 8 equals 1, right? All of those numbers are being used. Each time they just change the order of them. So once you know the multiplication, you actually also know the division of some of those as well. All right, next we'll be moving on to our 7s. In our 7s, we're going to look at our count bys as well. So let's look at our sets. If I've got one set of 7, I have 1 times 7, which equals 7. 2 sets of 7, 2 times 7 equals 14. 3 sets of 7, 3 times 7 is 21. 4 sets of 7, 4 times 7 is 28. 5 sets of 7, 5 times 7 is 35. 6 sets of 7, 6 times 7 is 42. 7 sets of 7, 7 times 7 is 49. 8 sets of 7, 8 times 7 is 56. 9 sets of 7, 9 times 7 is 63. And lastly, 10 sets of 7, 10 times 7 is 70. So go ahead and look at our 7s. Our products were 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. And see if you see any patterns when looking at those sets. All right, what are some patterns that we see? Well, one pattern that I notice is that it alternates. So 7 is an odd number, 14 is even. 21 is an odd number, 28 is even. So it alternates odd, even, odd, even, odd, even. That's one pattern that I see. Another pattern that I see is that if I ignore 70, and I do that little trick again where I add 63 plus 7, I get 70. When I add 56 plus 14, I get 70. When I do 56 plus, let's see, 1, 2, 3, 1, 2, 3, 56 plus, sorry, not 56. If I do 49 plus 21, I get 70. 28 plus 42, I get 70. So you can see that that pattern works all the way up to those 5s. We can also look at our division and see if we can see any patterns. Oops, we jumped here. Let's see. Let's look at our division here. And again, you'll notice that they all correlate. So let's look at our 2 times 7 equals 14. If I reorder that, 14 divided by 2, it equals 7. 14 divided by 7 equals 2, right? It doesn't matter. If I know my multiplication, I also know my division when I look at the patterns. All right, Now with both our 7s and our 8s, strategies that you can use to solve them if you don't know them. One of that great strategies is using your 5s, right? Let's say I'm trying to figure out 7 times 7. If I know my 5, if I know 7 times 5 is 35, and I'm stuck at how do I get to 7 times 7, all I have to do is think about, okay, well, how many more sets of 7s do I need? Well, I've done 5 sets. I need 2 more to get to that 7 times 7. So if I do 7 times 2, which I also end up knowing, or I know that 7 times 2 equals 14. If I add those together, then I end up with 5 plus 4 equals 9, and 3 plus 1 equals 4, which is correct because we know that 7 times 7 right there is 49. Another strategy that you can use is kind of doing that, just adding multiplication facts that you do know. So let's say I'm trying to figure out what, I'm trying to figure out what 6 times 7 is. Okay, I'm trying to figure out what 6 times 7 is. Well, let's say that I know that 4 times 7 is 28. I know that one. Again, I'm trying to get to what 6 times 7 is. Okay. So in order to get to 6 sets, I'm going to have to add 2 more on, right? So if I do 2 times 7, I know that that equals 14. Forgot to write my 7 there. All right. And then I add those up. So 8, 9, 10, 11, 12. 2, carry the 1. 2, 3, 4, 42. So 6, so 4 plus 2, which is 6. 6 times 7 equals 42. So it worked. So those are some great strategies to use with both your 7s and your 8s if you get stuck and can't remember. The last thing that we're going to be talking about is we're going to look at a couple of word problems to practice solving. All right, here's one. It says, Julian arranged his swimming trophies on 8 shelves, and I like to circle my numbers here, above his dresser. He put 7 trophies on each shelf. How many trophies does he have? All right, so he has 8 shelves. 1, 2, 3, 4, 5, a lot of shelves. 6, 7, 8 shelves. He put 7 trophies on each. 1, 2, 3, 4, 5, 6, 7. Now I'm not going to write all of those out, but what could I do to solve those? And you're right. If you said, well, you could multiply. I'm going to do 7 times 8. Now, that might be a hard one for some of you. So I'm going to start with something I do know. I know that 7 times 5 equals 35. And I am, let's see, I'm at 5 and I need to get to 8. So I'm 6, 7, 8. I'm 3 sets away. So I have to do 7 times 3. I'm going to try adding these together. 7 times 3 is 21. And then remember, I just add these together, right? Because I know that if I added 5 plus 3, I would get that 8, right? So I'm going to add these together. 5 plus 1 is 6, and 3 plus 2 is 5, 56. So 7 times 8 is 56. You can see how I can use my strategies to help me even solve word problems. All right, let's see. Let's do one more. 6 students from Maylee's class baked cakes for their school cakewalk fundraiser. They each bought 6 cakes. How many cakes are there in all? You can work on solving that one on their own. Again, there were 6 students and they each brought 6 cakes. And if I would go to solve this, I would do my 6 times 6, which ends up being a total of 36 cakes. So great work today. We reviewed our 7s and our 8s. and we also talked some strategies.